Hello students. So we have already studied about the structure of atom and nucleus. Now let's move on with the next topic, that is the isotopes. So in isotopes, it is nothing but it is the atoms of the same element that have same atomic number, which is represented by Z, and different mass number, which is represented by A. So as it is the same element, they have same place in the periodic table. They have same place in the periodic table. So as they have same atomic number, the number of protons and electrons will be same. But the number of neutrons, that is A minus Z, so only this will be different. Now let us understand it briefly or deeply with an example. So as you know, H is a symbol of hydrogen. So hydrogen is having 3 isotopes. So the first isotope is H11, second is H12, and the third isotope is H13. So the first one is called as the protium, the second one is called as the deuterium, and the third one is called as the tritium. So as you can see here, atomic number is same, that is 1, but the mass number is different. This is having 1, 2 and 3. Now let's see number of neutrons in each of it. So number of neutrons in the protium, or in the first one, is 1 minus 1, that is 0. So this doesn't have any neutrons. In the deuterium, that is the next one, second one, so 2 minus 1. So there's only 1 neutron. And in the third one, that is the tritium, we can see there are 2 neutrons. So as I told earlier, the neutrons, that is A minus Z, these will be different in the same element. So let's see number of protons. Protons is 1. What about electrons? It is same as that of the atomic number, that is 1. So as the electrons are same, they have the same chemical properties. Basically, the chemical properties depends on the electrons. So, same number of electrons means same chemical properties. Now, let's move on to the second example, that is carbon. Carbon is denoted by, or the symbol is C. So, C is having 3 isotopes again. Okay. So, let's see. The first isotope is C12,6. Second one is C13,6. And the third one is C14,6. So, in the first one, number of neutrons is 12 minus 6. So, how many neutrons are present in the first one? That is 6. In the second one, neutron is 13 minus 6. So, 7 neutrons are present. In the third one, number of neutrons is 14 minus 6. That is 8 neutrons. So, in all these 3, the number of neutrons are different, but protons are same because the atomic number is same. So 6 protons, number of protons is always equal to number of electrons. So 6 electrons. Now let's look into the last example, that is the chlorine. So chlorine is having only 2 isotopes and it is in the ratio 3:1. So the first isotope is Cl3517 and Cl3717. So here you can see mass number of first one is 35 and second one is 37. So what about the number of neutrons? So it is 35 minus 17, that is 18 neutrons are present. In the second one, we have 37 minus 17, that is 20 neutrons. But here, what about the number of protons? It is same as that of the atomic number, that is 17 protons and 17 electrons. So, same number of electrons, hence same chemical properties. Tin, whose symbol is Sn. So, this is having large number of isotopes. So, this is the one which is having higher number of isotopes. Now, let's see two different isotopes. One is the stable isotopes and the other one is unstable isotopes. Stable isotopes and unstable isotopes. So, unstable isotopes, it is also called as the radioactive isotopes. What is the difference is, in stable isotopes, number of neutron is nearly equal to number of protons. But in unstable, number of neutrons is higher than number of protons. So because of this, they have or they undergo radioactive decay. They undergo radioactive decay. So because of this radioactive decay, they have many uses, especially medical and industrial. They have medical and industrial uses. One of the example is uranium. The symbol for uranium is U. Okay, let's see how the number of neutrons are more than number of protons. So, uranium, they have again two isotopes. So, uranium 235-92 and uranium 238-92. So, in both of this, you can see 92 protons and 92 electrons. But what about number of neutrons? That is 235 minus 92 and 238 minus 92. So here you can see number of neutrons is more than number of protons. So this is about isotopes. Now let's move on to the next topic called as isobars. So these are also same, just like that of the isotopes, but here atoms of different element. In isotopes it was same element, but in isobars it is different element, which is having different atomic number, which is represented by Z, and same mass number. They are having the same mass number, which is nothing but the nucleons, and which is represented by A. Now let's see with the help of example. So I am taking two different elements, right? So atoms of two different elements which is having different atomic number. So the atomic number of sodium is 11 and magnesium is 12. And the mass number is 23 and 23. So different atomic number but same mass number. So let's go into number of protons, electrons and neutrons. So protons is 11, electrons is 11 and neutrons is 23 minus 11, that is 12 neutrons. In this, number of protons is 12, electrons is 12 and neutrons is 23 minus 12, that is 11 neutrons are present in magnesium. Okay, so let's see another example, that is carbon and nitrogen. So atomic different element, atomic number of carbon is 6 and nitrogen is 7. So different atomic number but same mass number, that is 14 and 14. So here protons is 6 electrons is 6, whereas neutrons is 14 minus 6, that is equal to 8. In nitrogen, proton is 7, electron is 7, and neutron is 14 minus 7, which is equal to 7 neutrons. So, in both of them, you can see number of protons and electrons, they are different. So, number of protons or electrons, which is nothing but the atomic number is different, right? But number of nucleons, that is the mass number, is the same. So, number of nucleons, that is mass number, is same. So, here also the same thing, number of protons and electrons are different, but the mass number is same. Now, in this example, you can see the number of protons, correct, in sodium is 11. And number of neutrons in magnesium is 11. And the number of neutrons in sodium is 12 and number of protons or electrons in magnesium is 12. So basically these are interchanged, correct? Number of proton is interchanged with number of neutron in the other element, and number of proton of one element is interchanged with number of neutron in the other element. Hence these are called as the mirror isotopes. So these are called as mirror isotopes. Now let's move on to the difference between isotopes and isobars. So as you already know, isotopes of the same element, they have same atomic number, which is represented by Z, different mass number, which is represented by A, correct, which is also called as nucleons, and they have same place in the periodic table. They have same place in the periodic table. So let's see about isobars. So different element, correct, different atomic number, which is represented by Z, same mass number, which is represented by A, which is also called as nucleons, and they have different place in periodic table. So these are the difference between the isotopes and isobars. Now as you already know, the example for isotope is H11, H12, H13, or different. There are many other examples also. And for isobars, it is say 14, 6 and N14, 7. Correct? So this is the difference between the isotopes and isobars. Now let's move on to the next topic, that is tones. Okay, so here it is the atom, so in which number of protons are different, but here number of neutrons are same. So number of protons will be different, but number of neutrons are the same. Now let's go deep into it with the help of an example. So Na and Mg. Na 1123 and Mg 1224. So number of protons in sodium is 11. Number of electron is also 11. But neutron is 23 minus 11, that is 12. So in magnesium, proton is 12, electron is also 12, but neutron is 24 minus 12, that is 12. Okay, so here you can see number of protons here and electrons are different, but number of neutrons are the same. So this is about isotones.